All right, so section 8 through 19. This one's going to take a while, the way it goes. And before I do anything else, I just want to remind everyone that the first thing that you look for is the greatest common monomial. Second thing that we look for is a difference of squares. I'm going to just abbreviate this. Third thing is a square binomial. Fourth thing, if we can't find anything else, we're looking for a binomial pair of factors. And then when all else fails, we're stuck with grouping. And I'm going to take a picture of this so that I can leave it on the board and erase everything else quickly. Must have my sound off because we didn't get the nice little camera sound. And I'm going to put this over here so I can keep referring to it over and over and over again because I love factoring checklists. All right, so in question 8, the first thing I'm going to look for is a greatest common monomial. And I notice that 4 goes into all of them. And I notice that a, the smallest degree of a is a to the third. So we know an a to the third goes into all of them. And the lowest degree of b is b. And so now that part, the greatest common monomial, goes on the outside. And I'm going to divide all of these by my greatest common monomial. So 4 divided by 4 is 1. A to the fourth divided by a to the third is a. B squared divided by b is just b. All right. Negative 8 divided by 4 is negative 2. A to the third divided by a to the third is 1. B squared divided by b is b. Finally, 12 divided by 4 is 3. A to the third divided by a to the third is 1, and b divided by b is 1. And looking at this, I'm pretty sure there's nothing more that I can do with this. So this is my final answer. It's just the greatest common monomial. All right, next problem, number 9. First thing I look for is a greatest common monomial. And it's pretty clear there are no greatest common monomials. Stop spraying the water in your hair, goofball. 8-year-old girls do the oddest things. You're soaking wet. All right, so no common monomial. Could this be a difference of squares? And now let's see. A difference of squares will have two numbers that are perfect squares most of the time. You could have a trinomial, but let's not get into that. So you have most of the time a binomial, and your binomial has two perfect squares. Oh my goodness, I have that. And you're subtracting them because it's a difference, which means subtraction. That's a difference of squares. And a difference of squares will always be factored by a pair of binomials. One's going to have an addition, one's going to have subtraction, and we're just going to take the square root of both of these terms. Square root of 16c squared is 4c. The square root of this one is 7d squared. And now, because of the squared, I do have to worry about it being factorable again, but I have no greatest common monomials, and 7 is prime, and I have no trinomials, so there's a good bet I am done. And in reality, I am done. Not too bad so far. Living by the checklist. All right, number 10. Look for a greatest common monomial. I don't have one. Difference of squares, well, this is a trinomial, and I have an addition sign, so this definitely cannot be a difference of squares. Is this a square binomial? Well, let's see. A square binomial has two perfect squares on either end. As a trinomial, good so far, and the middle term is going to be 2 times a times b, and that is a 2, and this is a b. Really playing at home. Well, so this could be a square binomial, the third thing. And so if it is, I'm going to grab another pen because this one is driving me crazy. And of course, right when I want another pen, it isn't showing up. So I'll just go on. So a square binomial will be a binomial squared. And so What is the square root of e squared? Well, it's e. What is the square root of 25? It's 5. 5. Okay. And so then it's going to be subtraction because my middle term, my linear term, is negative. And so for this to be a square binomial, my a value and my b value, my linear term is going to have to be 2 times a times b. So I have 2 times e, that's my a value, times negative 5, that's my b value. And lo and behold, I do get negative 10 e. So this is my answer. And yes, you have to perform this checking. All right. Number 11. Do we have a greatest common monomial? No. Do I have a difference of squares? Clearly not. I have 2 subtraction signs. I have no, 42 isn't square. Do I have, 42 isn't a perfect square, so I don't have a square binomial. I have to do a binomial pair of factors. Now, I don't care if you do your rectangles. And figure out, g times g, here's my h, here's an h. Or doing your factors of negative 42 times, and that has a sum of negative 1, because yes, folks, that is a 1. Either way is fine. I like this way slightly better. It's a little more organized list of data, so I'm going to go with it. So what times what is negative 42? Well, I know that 6 and 7, so let's say negative 6 and 7. Well, what is the sum of negative 6 and 7? It is positive 1. Oh, so close. I want negative 1. So how about negative 7 and 6? And I have a wiener. So I'm not done. I have to put it into my binomial pair. So I know g times g is g squared. I know h times h is h squared. And now I just have to import my numbers. And there you have it. All right, number 13. Number 13. First thing I look for is a greatest common monomial. So close, but no cigar. Then this is not a difference of squares because I have a positive sign. I look for a square binomial. This is not square. So binomial pair of factors. And this is the possible factors, possible sum table that I taught. Now I'm going to do this a little differently. What I like to do is I like to write the 2 numbers here. And let's have some factors. We have 2 and 4, 1 and 8. Here we have 5 and 7. I have negative 7, and let's try negative 5 and 7. And so I want, because this is a subtraction, I know we have 1 positive, 1 negative down here. I want 2 numbers. I want to multiply 2 numbers together from here and here, and the products are going to be 6 apart. So I'm looking at this, and I see we have 4 times 5. Oh my goodness! If I do 4 times 5 and 2 times 7, if I did that, I would get positive 20 and negative 14, and now I add those together, I get 6, positive 6. That's really great. So that means the 2 and this negative 7 cannot be in the same binomial. So we go 2, and what's my letter? J. We have and so then we have 4j. And then the 7 has to be away from the, oh my god, it's driving me crazy. Using the finger here. And then the 5 has to be on the opposite other binomial from the 4. So we have plus 5k. And there we have it. I really like doing this a lot better than the other way. I find I can do it quicker. I don't know. All right. I'm going to actually stop the video here so it doesn't get crazy long and do the rest of them in another video.